Hello there everybody and welcome back to this series. Now if you're watching this in a few months time and haven't experienced a 4-month delay between this episode and the previous episode, bear with me because I will get to the redstone and to the real point of this video shortly. But first, I owe a massive apology to all those who are watching this video as I am releasing them, so as I'm uploading them. That's because I haven't uploaded in, 3 months now? Getting on it, I think last uploaded about June time, but that wasn't even a computer video, that was something on Feed the Beast probably. So yeah, probably 3 months, maybe even 4 months since I uploaded the last part of this episode, so I am greatly sorry for that. I didn't mean for that to happen, I never intended it, it's just things happen with my computer and with me starting the next year in my high school. By far the busiest and most hectic so far, and I just really haven't found time to make the videos. But it's not just that, it's also, like I said, my computer is getting old. Well, not getting old, but getting on a little bit, and the hard drive broke, and the GPU chip, I think it was, the connections to from the CPU to the GPU chip or something along those lines, they were faulty, so I was getting B-sods from my GPU and I was getting B-sods from my hard drive, and I was getting B-sods while playing Minecraft while rendering. Even when moving my laptop I was getting B-sods, B-sods being blue screens of death, crashes basically, whenever I did anything, so it wasn't great and I haven't been able to upload anything. But I managed to fix that just towards the end of last month, end of September. I got that fixed fully and I can make videos again. But like I said, there isn't a schedule, and there'll probably be one-off videos I'll try to get one a week, but I don't know. It's all a bit hectic at the moment. Year 11 is a pretty big year in England in terms of education, because you have your GCSEs, which are your biggest exams yet, and are they the equivalent of finals in America? I'm not sure, but yeah, it's pretty hard. Anyhow, so that's what's been happening, and I need to get back to this video. Right, so while I've been away, I've actually done quite a lot. I haven't just sat on my backside thinking what to do with fixing my computer. I got on with this and I fixed some of the bugs which are in this computer, and did some of the really boring tasks which couldn't be done on camera just due to their length and how time consuming they were. Alright, so where do we leave it? I think we had just completed this bus here. Now I know in the last video I think I just garbled on and didn't say a right lot about computers or anything useful, but I think we completed this bus here, which goes over to the RAM, and this bus here, which goes over to the RAM addressing system, i.e. the RAM decoders over here and over here. And as you can see, the RAM decoders have magically appeared where they weren't there before. Right, so that's the first thing that I've done. I have built these decoders. First of all, I need to give you a quick explanation on what they do. Right, so let's go right back to the address register down here. So this holds the address you want to use in your RAM. So that's writing to RAM or reading from RAM. So this holds the address. At the moment it holds nothing because obviously the computer isn't running. So this address comes up here in binary, of course, comes up here, goes along this bus, and now as we have quite a small pool of RAM, quite a small block of RAM, we don't actually need these 3 bits here, so they're just ignored, and if we use those that'll generate an error. I'll get to explaining that in a bit. But yeah, so the address, the 5-bit address, comes over here and it goes into these decoders. Basically all these decoders are is they translate a binary address into a decimal. So they convert 1s and 0s into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And yeah, it's not terribly difficult. I showed you one of these in a much smaller version over here, and I will use these to demonstrate. So by default a 0 comes through here. This was another little change. I changed these slightly. Anyway, so yeah, by default a 0 comes through, and a 0 is being entered and 0 is outputted. We input a 1, the next one turns on. We input a 2, and the next one, the second one turns on. Imagine we're starting at 0, so 0, 1, 2, 3. So we input a 0, that happens, input a 3, and that happens, so we input a 2, we input a 3, and so on and so on and so forth. Oop. So that's all that's happening over here. So if we were to input something into our decoder, what shall we have? Pick a number, any number, I don't know, 13. So what do we want? 1, 2, 4, 8. So 1 and 8, a 4, and a 1. 13. That gets sent along here, nothing special. Some of them are inverted earlier than others, that's just because of the busing. And we get a 13 on our decoder, reading from right to left, so 1, 0, 1, 1, 0, 13. And if we take a look at the outputs, which are along here, they're kind of hard to see. They're actually these repeaters here. A 13 should be outputted wherever the 13 is. Oh, let's just set that to 0, and then I'll be able to show you where it is. 13, where are you? Is it here? And we found it. Okay, so the 13 is here. And if we were to count, that should be 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Perfect, so the 13th address is being decoded. Don't ask me how these decoders work. I explained it in another video. Basically, it's just piston placement, whether they're up or down. And the up and down representing the 1 and the 0 is really easy. I think I've got a video on that separately, but it's not hard to make, and I will provide a world download with all this in, so you don't have to build it yourself. Okay, so that's what happens with the decoder. The address goes into the decoder as binary address and comes out as a decimal. And it doesn't only go to this decoder, it goes to this decoder too underneath, because as you hopefully remember, there are two things you can do with RAM. You can write to it and you can read from it. So these are the this is the decoder for writing, and this is the decoder for reading. Hopefully you're sticking with me. This is going to be quite a long explanation. So as you can see, the buses somewhat messily make their way down here, and as you can see, we are actually inputting 13 to the second decoder too. Ignore why this is on for the moment, I will get to that later. So we're actually inputting 13, imagine that's off. And now you might be wondering, the smarter of you lot, might be wondering, why are we reading and writing to the same address at the same time? We obviously don't want that. We want to specify whether we want to read from RAM or write to it, because reading and writing at the same time is not really very useful. And this is where this little piece of redstone comes in. Now, I obviously needed to find a way to determine whether we want to read and want to write, and that will obviously be specified by the user at the time, depending on what they want to do, the instruction. So this little switch controls it. So when it's a 0, when the switch is off, a 0, we are writing, and when it's a 1, we are reading. So now to explain this thing. Right, this was, I don't know, there's no set way of doing this, kind of, I don't know, kind of slow. Well, no, it's only about 3 ticks, but it works perfectly. Right, so when this is a 0, so when this is off, it gets inverted first, and then that signal is sent along this huge long line all the way to the end and all the way to the other end. And they control, ooh, if I can get back up, they control these torches here. And now these torches are obviously off at the moment, meaning that these pistons, which, ooh, didn't mean to do that, which, unless you're going to make drop block, drop block, same thing. So obviously these torches are controlling the pistons, because they're in like the range and they power them. So when this is off, basically these torches are off, these pistons are retracted, and the signal coming out of the decoder, out of these repeaters, can go through the block, power the block, and send it along the write lines, which I've already explained how this RAM works. So you should know what these do. So that's what happens when it's a 0. And if we go down here, I should be able to show you why it stops the this from coming through. Alright. So when it's a 0, it enables this to come through, but that's only half the story, isn't it? We need to disable the read lines. Now this was a bit more complex than just one piston because of the pattern we had here, and I couldn't really have a piston powering a block like up and down there because of all the redstone blocks around. Just wasn't physically possible, even though there seems to be more space here. So anyway, yeah, the way I did this was rather neat. So the signal actually comes down from this long line that I just told you about a minute ago, unpowers this torch, unpowers this redstone, which then powers this torch. This torch then powers this line, and as you can see, this line is connected to all of the pistons, like the final pistons before the repeaters. And since these are all powered, they extend, and obviously no signal whether or not anything is coming through here. So let's see, let's demonstrate. Okay, so at the moment, so all of these are off, so the signal is getting travel through here, but obviously this is extended, so it's not going to get any further, and it's been disabled. So that's what happens on this half of the decoder. Now if we go down here, the other half, we have another clever bit of redstonery, and this is where this piston comes in. So this line is off, which is like I said, powered by the line up there, just gets transferred down here. So this is off, meaning that this piston is retracted, and this blocks the power coming through here. This means that no matter what is inputted from the user, which actually comes down from here, the signal can't travel along here, so these can never be on, and therefore they never allow any signal through regardless of what is coming through here. So as you can see, it's getting powered all the way through. Imagine this was up, this would be powered, but this is up, so no power's travel through, and that happens. So yeah, that's kind of how that works. A little bit complicated, but really not too hard a concept. Alright, so we need to now do something else, and that is to demonstrate what happens when this is on. So obviously the opposite happens, these extend, not allowing any signal through. The signal is then sent down somewhere, I don't know where it is, gets sent down here, there we go, gets sent down here. This is turned off, so these can act normally. So if they are powered by the user input, which is coming down from here, that's just getting bussed all the way from here. So yeah, that's not too hard. So if that was on, obviously this torch isn't now affecting it at all, so these can behave normally. And as this line is on, this piston is again extended, allowing the signal to travel along here and allowing these pistons to act normally too. So that's how that little mechanism works. It was rather annoying to fit in, but it's entirely necessary. So that's it for the read-write decoders, and that's probably the majority of this video done. Now it's just for a quick few bits. Right, so once we've read from address, we obviously want the output to go somewhere. It's no good saying read from this and the output just staying somewhere. What we actually want to happen is for the output to come out here and go back into our general purpose registers, so they can be accessed immediately by the ALU and computed on at any given time. Ooh, bit of glitchy redstone here, not too good. So that's exactly what I did. I took the outputs from the RAM, which just come out of here. They're all attached to the same lines going all the way along there. I took them out of here, bust them over the top of each other to save space and save a couple of ticks on repeaters, and basically just bust them back into the inputs of the GPRs. So we could give the computer a command like, I don't know, read from address 28 from RAM and store in GPR2, and that'd be really easy because we just pass it the value 28 to the address decoder, to the RAM decoders, set it to read by setting that to 1. Whatever value is stored in address 28 would then get sent through the outputs, and we actually do have an output, something must be stored in there. and then these are then sent along here and back into the general purpose registers. We then specify the address on the general purpose registers, which I said was 2, and boom, we've just simulated a computer cycle. The value has been written into address 2. Perfect. So that is pretty much all that's for the RAM. There isn't really much else to say. It's working perfectly now, and hopefully that is it. We shouldn't need to come back to the RAM, except maybe for changing this flipping red. There seems to be a whole mass of red here, and it's ruining my colour scheme. So if you guys have got any other colour suggestions, I will gladly hear from them. Hear from you, should I say. Right, before I release the world download, I will hopefully wipe all of these registers clean, wipe all the RAM clean, wipe all the registers clean, and give you like a fresh copy, should I say. So that means there won't be any values in the RAM, which, as you can see, there is an awful lot of values. I think an up is designates a value, and a 1 and a down represents a 0 because it's inverted. But yeah, I will get all of this cleaned and wiped. Take me a bit of a time, but I promise I will get that world download perfect, and it will be uploaded as soon as the video is uploaded, if not before. Right, so that's the RAM. What else is there to say? Nothing else really, except a couple of other minor fixes. One being this decoder here. Now, before I had loads and loads of pistons somewhere along the lines of, like, something along the lines of that. That was just to stop a load of buds happening, and I realised, or someone told me on Minecraft R, that you can use half slabs, and that works perfectly. So that's one of the fixes I did for this. The other fix I did was to make the decoder start at 0. Before, it started at 1, meaning that you had to input a 1 to get anything being decoded, any function for the ALU to be decoded. And that's not great because it limits the number of operations you can do in this opcode. By that I mean if you start at 1 you can only have 15, and if you start at 0 you can have 16. So yeah, I decided to do that. It only gains an extra operation, but it's more realistic, I think. I also added these here, and that was because a fair few people, well, not like 2, people have commented on my video saying that my method of accessing RAM is slow and inefficient, and I agree entirely it is. I don't actually use this method anymore, and I use a much better method, so I tried to incorporate both of them. The method I was using is to have an address register store the value coming out of the ALU which you want to use as an address. So say 5 was coming out of here, you save it to this address, and wait, we've got we actually have a value coming out of here for some reason. Oh yeah, because something's being odd. Anyhow, so yeah, that is now in the address register, and then so that will be 1 clock cycle to save it in here, and then it would take another clock cycle to send it to the address register, and then to read it, and to the decoders, and then to read it from RAM, or to write it to RAM. And that's taken 2 clock cycles just to access RAM, and that is fairly slow. I mean, in real life that's probably like 2/2000th of a second. Not really a big deal, but with that, with Minecraft computers, that's like, I don't know, 2.5 seconds, and that vastly decreases the speed. So I added this way where you can just directly specify the address you want to use from the program memory, from your code, meaning that it will only take one clock cycle to access RAM. A much better scenario, and I will also keep this address register here in case you want to use the value from the ALU also. Best of both worlds, I thought, and a clever little solution to a pretty big problem. What else? Alright, finally, I promise this is finally, it's been a long episode. I changed the colour of these, not a big deal, and I changed all of the white slabs in here to stone slabs, just because I hated half being white and half being quartz and half being stone. That is it, I think. So yeah, finally I am back to making videos. My computer's fixed. It's like the end of my hiatus, and hopefully I'll have some spare time in amongst the rugby and the football and the schoolwork to make these videos. So thanks for sticking with me if you haven't unsubscribed due to my lack of activity, and hopefully this video with all of the extra stuff that I've added in for you and got up to date will I don't know, will make up for the lack of videos over the past, I don't know, quarter of a year. So yeah, thanks for watching guys, please stick around for the next video.